Hello everyone, welcome back to another video from the Mental Forest. Let's continue our leetcode challenge. Today's question called a perfect square. Given a positive integer n, find the least number of a perfect square number, for example 1, 4, 9, 16, which is assigned to n. And let's look up the first example. So if we receive a number n equal to 12, then at the least number of square, it is 4 plus 4 plus 4 equal to 12. So the answer is 3. And the second example is 13. The 13, the minimum and square, we need 4 and 9. So it is 2. And for this question, we're going to use a DP array. So if it is a DP array, we're going to build from sub-question up to our answer. And for in here, we're going to, I just write array to see and if you could understand it. And also for DP question, so we don't definitely have a two-dimensional array, so two loop. And let's start it just use for example, if I give n equal to 10, so I started I position from, I could start with 1 because if 0 and it is 0, it definitely it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because we get the at least number, so if we find the, we always start the, we also pick up the last one. So this is the index we're going to loop. So we loop up to 10 to find it. Each time we loop, we're going to loop again. And now we have a array. In this array, DP array, the length is 10. And the first one, we know that 0 have a 0 n square. And the second one, you also know it is 1 because 1 square equal to 1. So this is a minimum. For 2, you're going to find it. You know 2 equal to 1 plus 1. So you need 1, it is 1 square is 1, 1 square equal to 1. So you action every time at the moment you see 0, 1, and 2. Now my I it is in here. Every time my I change, you are looping from the 1 and to 2. Find the minimum. I find 1, it is have a square, so I pick up equal to 1 and add 1, it is 2. And for now we move to the I equal to 3. We start looping, and how many I could form? I know 1 it is a square, and now have 2. We already have 2, and now we know it is could be plus 2 plus 1. 2 could have a 2 square, and we have a 1. 1 it is need at least 1, so this is 3. Now we move the I to here. And we start looping from here up to here, but in 4 it is special case. If this is a perfect square, this is perfect square, it means I equal to j times j. So we move from here to here. We already, when I equal to this one, we go into from 1 and 2. How? We found I equal to this one. So we know this is, we could stop in here. The looping from 1 and 2. We know 2 times 2 already equal to what we need, so we only need 1. Now we move to, I move to 5. So if we start from here, from 1, and if 1 smaller than the 5, you actually know, for the 5 equal to 2 plus 3, you know 5 actually equal to 2 plus 1. Did you see? Because you looping from here up to here 2 square, so 0, 1, 2 equal to 4. for here it is still smaller than 1, but you could add 1. So here it is 2. And once you up to the 6, so you actually could find it is 1. The 5 could is 1 square plus 1 plus 1. But you actually could find 2 plus 2 plus 1. 2 plus 2 plus 1, it is 2. 2 square plus 2 square, it is 5, still too big, so you go into 3. So you actually can find 3 plus 2. 3 plus 2, 3 need 3 square, 2 need 2 square, so it is still bigger. Then you up to 4. You looping up to this position. So 4, you find 4 only need 1 square. Then you add 1 square because 5 minus 4, it is 1 square, so it is 2 square. 6 do the same thing. You go into 5 just plus 1, so it actually is 3. And then you go into 7. You pick up the least one, so you always pick up the biggest number first. 7, it is 4. It is 6 plus 1. Then the A actually it is, you see, the A it is this one, 4, 2, 4, 4. You have a 2, 4, 4, so the A it is 2. And then you go into the 9. And then 9 it is A plus 1, it is 3. Oh no, sorry, that 9 is a special case. 9 because when you are looping up to here, you already, when you loop the I over there, so you looping from here to here, you must 0, 1, 2, 3. When you up to 3, this one already equal to here. So it is this number already, then you only need 1 square, and the 10 just 2 square, 2 plus 1. So you already found the pattern. So if I equal to j times j, so you just give dpi equal to 1 in here. You see 1, 1, 1. But if otherwise the dpi, you actually equal to the minimum. You start with the bigger one, dp 10 for here, 10 minus 9 plus d plus. Your action is from here, so dp 10 minus 1 plus dp 9, and then you compare dp 10 minus 4 and then plus 6, and you add so on, just compare with the minimum. So now just let as a write the code to reflect this pattern. So we're going to have a DP array. And by default, you actually fill out the DP array with the maximum, then you're going to replace them. We don't need looping up to try because we only need find up the max, only the root of this given number. So this two list, the loop, it is just a DP array pattern code. Because like for example in this one, I only need looping up the root of 12. So once I loop into 3, actually already found it. So like I said in here, if it is the square, you only need one number to form a number equal to this I. then you know this DPR definitely only need one. And else you're going to find if it is small, you already looped. So once you loop the I is greater than the already bigger than here, did you see? Bigger than this one. Like for example, you go into none, already bigger than the, you need a 4, that is why here need a 4. If already bigger than the j times j, then you just replace, get the minimum one. Then you add one. For example, in the 5, so j I in here you already bigger than this I square, so you actually it is equal to this one plus 1. So you compare the current one every time the DPI, you compare the I one and then the I minus j square one, which one is the small number, you pick up the smallest. Otherwise you're going to, you see, you in the 5 you could be 1 5 5, you could have a 5 1, you could have a 2 plus 1, you could have a 3 plus 1, but you will find this one, so use this one, add 1 equal to 5. That is what the code reflect in here. And once the 2 dimension you looping finish your DP array, then you just return the answer. So it is the last element. Just run the code and see if I have a syntax missing. Yeah, arrays, not array, arrays. Yeah, it's finished. Just tested, submitted, see if accepted. It accepted. Thank you for watching. Bye.